should be recording. Okay, now we're recording.
Yes, they can hear. I don't give you permission. I want to leave the meeting. Okay. Let me share screen. Podcast. There. Okay. So in this problem, you have to like I said in the review, you're gonna have to make the Hamiltonian depending on the amount of times in the molecule. So you have like, that's why I drew this here. So this has 1 electron. This has 2 electrons. Altogether, they make 3 electrons for the molecule. Now, how you're gonna make the Hamiltonian is like this. So what I do is I list the Hamiltonian like this. And let me just erase this a little bit confusion.
That's the equation.
Yes, that's the equation. So what you can do is you can write this term, you can write this down, and then you can split up your answer into parts. So for example, they want you to find the kinetic energy of the nucleus. This is a complete Hamiltonian, so that includes the nucleus. So this is a diatomic molecule. You're gonna have 2 terms: the kinetic energy of the helium atom and the kinetic energy of the hydrogen atom. And for the kinetic energy of the electrons, since there's 3 electrons altogether, you're gonna have 3 terms. I just distributed this out because all electrons have the same mass, so it's the same. So you get this part, right? I just distribute.
Yeah.
Okay, and for the next part, you're gonna have to deal with electron to the nucleus. Since there's 2 nuclei, I think you're gonna have 6 terms because each electron is attracted to the other to the hydrogen or the helium. So you're gonna have this right here. So this is electron 1, electron 2, electron 3, and those can be attracted to the hydrogen nuclei, and they can also be attracted to the helium nuclei. And then we have electron-electron repulsion. So what you do is you just like in multi-electrons, you count the interactions, but you don't count the interactions twice. So E squared over R1/2 would just be the interactions between electron 1 and electron 2, and this electron between 2 and 3, and this is interaction between 3 and 1. So I don't have electron 2 and 1 and 3 and 2 because that'll be a counted interaction twice, and you don't count the interaction twice for. And then finally, you have the repulsion between the 2 nuclei, and then that would just be 1 term. So there's one nuclei. I mean, there's 2 nuclei between each other, and they can each exert force on each other, which is just 1 term. And this is the charge 1 times 2, so it'll be like 2 E squared. And since I forgot they asked for atomic units. So if they're asking for the atomic units, you would just cross out the E, and it'll just be 1. So for everything that has E squared, it'll just be 1. Does that make sense?
Okay, can you explain that again? Why E squared will be 1?
Because they're asking for atomic units, and atomic units doesn't include the charge of the electron. When you convert into atomic units, the charge of the electron just cancels out. I mean, not cancels out, but just turned into 1.
Okay, so that's for part B, right?
That's for part A. I just forgot to remove the E squared. So just wherever you see E squared, just put 1. That makes
yeah.
Okay.
That makes sense. And what about the those A? What does A represent? Like for?
Oh, that's just the equation. So that's just the equation. So A can be between A. So A can be hydrogen and helium. Since we have two atoms on a nuclei, we have A could be just helium or hydrogen. So it's basically just like, oh, we have this. Yeah, basically, yeah, that's what it is.
Okay. Okay, I can see that. And then what about the part B for electronic Hamiltonian operator?
It's just basically the same thing, but just don't include this. So if you have the question and they're asking you to write the electron Hamiltonian, just write this whole thing and just say the terms are in the previous part A.
Okay, so electronic Hamiltonian operator doesn't have a kinetic energy.
It doesn't have the kinetic energy of the nucleus because in electron Hamiltonian, we assume that, and sorry about the background, we assume
Okay.
that nuclei is fixed, so we don't count the acidic energy of the nuclei.
Okay.
That makes
Okay.
sense?
Yeah, and then I just cross out E square for if they are asking for atomic units.
Yes, and I wouldn't use that wording cross out, just say equal E squared to 1.
Okay, okay.
All right. Is there
Okay.
any other questions besides this?
And C and D, of course.
E and D? Okay, I just want to let you know, just memorize, I won't say memorize, but just have in mind these equations here. And they'll help you figure out how to do this problem.
Okay.
For part C, it is asking for the electronic discuss the orbital diagram for HEH that you labeled the molecular orbitals. What is electron? Okay, so basically what they want you to do is make the molecular orbital. You took inorganic chemistry, right?
I didn't, but I think I can understand.
Yeah, okay. So it's easy for people to, but it's basically just so you know helium is a noble gas, right? It has like 2 electrons in its 2 filled electrons in a 2s orbital, which means it's stable. So it has a lower energy. So it's right here. And hydrogen is right here. And since if we're dealing with atoms that are like helium and hydrogen, then you're gonna have, okay, so you're gonna have like a 1 sigma G for the first orbital and 1 sigma U star. And the star just means antibonding. Let's put that.
Antibonding. So every like noble gas has like not n-type bonding, so it doesn't have a star, and then H means, n-type bonding.
Not I meaning that in this case the molecular orbital. I'm talking about molecular. This is the molecular orbital of the whole molecule. So it's not the orbital for helium.
Can I say like I have 2 electrons for helium, and that completes a whole, and then I add 1 more electron, then it doesn't have a pair, then it'll be antibonding.
It's antibonding when there's electron in this orbital. If you're saying wait, what are you specifically you're asking?
What?
What is it specifically you're asking? Are you asking I'm sorry, it's like I'm a little confused on what you're asking.
I mean, for hydrogen, I only have like 1 electron, so then
Yeah.
it does. So does that make it antibonding?
No, it doesn't have to deal with that. It deals with the electrons. So basically, when they interact with each other, helium and hydrogen, they make molecular orbitals, and these molecular orbitals are not for helium or not for hydrogen. They're for both of them for the molecule. So when you're saying, if you're saying they're not going to directly ask you, they're probably going to ask you, is there electrons in the anti-bonding orbital or something like that, and you're going to say yes because there is.
Okay.
So
Then what about He2 plus? Can you also draw that, please?
He2 plus.
Yeah.
Did they ask you for He2 plus?
It's on spring 2021, actually. But
Okay.
yeah, they did ask for sketching it.
Oh, okay. So He2 plus is basically just the same thing, but it's just actually I can just write this. I'll just put it back. It's basically without 2 electrons. Oh, come on. There. So it's not 2 electrons.
Oh, they only have 1 electron.
Yeah, it's just 1 electron here.
So So for H plus, that's where we have two electrons. So that two electrons belongs to, you know, helium. Is that
It
correct?
doesn't belong to I wouldn't say it belongs to helium. I would say it's just in the overall charge of the molecule. So when you're talking about molecular orbitals, don't talk about each atom separately. Just talk about the molecule itself.
Okay. So when it's two electrons, there will be like two arrows
Yeah,
at the
yeah,
bottom.
yeah.
Okay. Okay, I
That's
got that.
for helium plus. I mean helium hydride plus. Okay, and let me just erase that.
And if it's four electrons, then it'll be, four arrows.
Yeah, exactly.
Okay. Okay. So what about D? Part D.
Part D. Did it ask you directly for this, or did it ask you anything different?
What was that?
Did it ask you specifically about these here?
Yeah.
Okay. I just want to make sure. So for helium, so basically, bonding order has to do with the number of electrons and bonding in the bonding orbital minus the number of electrons in the anti-bonding over 2. So in this case, the number of electrons in the bonding orbital is 2, and the number of electrons in the anti-bonding is 1. So then you subtract, you get 1/2. And then from the rest, so it will be 1 less electron in its anti-bonding. So there's no electrons in the anti-bonding for helium H plus.
And be 1.
Yeah, so it'll be 1. And then for the next, it'll be 2 minus 2. There's going to be 2 electrons for He H minus, and that's going to be 0 for the bond order. So that's basically how you do bonding order. And for the next part, it's asking you which one of the 3 species is the most stable. So what you would do is you would find the molecular orbital. You'll find the electrons that have the less you'll find the molecular atom that has the less electrons in the anti-bonding orbital. So in this case, it will be H plus because it doesn't have electrons in the anti-bonding orbital.
Oh, okay.
If we're talking about order 2, it will be H plus first, then HHE, then HHE minus.
Okay.
That makes sense, right?
Yeah, that makes sense.
Okay. I skipped over this. If we're talking about electron configuration, it's basically this, and then the number has to deal with the number of electrons in that orbital. So if you're talking about your case where it's He2 plus, then it's going to be 1 sigma G1. Does that make sense?
Yeah, that makes sense. And then for the later part, it doesn't have that one. So it's just be like 1 sigma G1.
Yeah, for H, you're talking about He H plus 2 plus. Yeah. Okay. Yeah. Exactly.
Okay, I got that. And about the energy level, is it the same like like a sigma G with 1s and then 2s stuff?
Wait, what are you talking about?
Like the energy levels, for example, is 1 sigma G equals to 1s?
It's actually lower than a 1s orbital, because when you really think about it, when molecular orbitals interact with each other, the molecular orbital is lower in energy, because the reason why atoms bond is to lower in energy. But when you lower the energy, you also make an anti-bonding orbital, which is higher in energy than its atomic orbit than each atomic orbital. So in this case, this is lower in energy than the atomic orbitals, and this is higher in energy than the bonding orbitals. Does that make sense?
Yeah, okay. So they all like in 1s.
They're, I guess 1 sigma G would be lower than the 1s orbitals on H and He. Then for 1 sigma U star, they will be higher in energy than the
Okay, I see.
one. Yeah.
Okay, thank you.
And that's it. That's all you got.
Yeah,
All right. Awesome.
thank you.
No problem.
I had two questions.
Oh yeah, sure.
Okay, so one of them was on the practice exam, so I can share my screen.
Yes. Share your screen.
Okay, so for problem 3, I was looking at the solutions, but I didn't, they did it a different way, like part A too. They did it a different way, and I got the same answer, but I did it another way. So for part B, I tried doing, like, I did it a different way as well, and then my answer was like, I think it was like 200 below the actual answer. So I just wanted to go through the way I did it and see if like I can actually do it that way.
Okay. Yeah. Did you do
So,
it? Oh, sorry to interrupt you.
sorry.
I was just gonna say, did you do it? You use reduce mass, right? In your method? You did?
Can you repeat that?
You used the reduce mass, right?
Yeah.
Okay, then all right. You can I guess show your I mean, how did you do
Yeah.
it?
So
Really?
I wrote it on paper. But I first I got B through let me go back to the question. So I got B by using the 224 110, and then the 2 3 I use like the FJ equals J plus 1B.
Mhm.
Yeah, for part A, right? That's how I got B. And then I did B, so like you know how B equals H bar squared over 2IHC? I just took the H bar squared over 2HC as like a constant.
Okay.
Well, yeah, that times R squared as a constant, and then I divided that by the reduced mass. And
Oh
then,
yeah, yeah, okay. I see what you're
yeah,
doing.
and then I got C by multiplying the reduced mass by B for the 39K 37Cl.
Yeah.
And then I divided that C by the new reduced mass to get
Oh,
the new B, and then multiplied that by 2 to get the 39K 35Cl
okay, so
frequency.
all right. Did you said initially, I got what you said, you got your old B, right? And you divided it by the reduced mass, or you multiplied by reduced.
Yeah, I divided it because it was
Okay.
H bar squared over 2 mu R squared HC, right? So I just took the constants, and then the mu was on the bottom, so that's why I divided.
You're supposed to multiply actually, because it's on mu is on the bottom. To cancel out mu, you have to multiply it.
For B, or
Yeah, for B, yeah.
yeah, I multiplied by B. So let me try writing it down because I know it gets confusing. So all right, so B. So I had this, right? Like that's the
Yeah.
original equation for B. So then I took everything as a constant
Yeah.
except mu because R is independent. So I had one, that's a one, 1 over the reduced mass equals B.
Okay.
Or not 1, sorry, it's not 1. I took it as a constant, so it's C, right? I just named it C. So
Yeah.
C over the reduced mass equals B. So I had to multiply the reduced mass by B to get C. And
Wait,
then does that make sense?
but You want to, what you're trying to do is find C. Oh, wait, I get it. Okay, continue. Yeah.
Yeah, so then I figured C would be the same, which I'm not sure about because I guess the R could change, which could change the C value.
You're perfectly right. C wouldn't change.
It wouldn't change? Okay. So then I can divide this C by the new reduced mass, right? To get B.
Yeah. Yeah.
And then multiply it by, well, from 0 to 1, it's like
Oh, wait.
2B.
Yeah. Okay. Yeah. Wait, did you multiply it by 2B and then you get your answer, or 2B and wait, 1 second. Let me go to the question. The way you did it is actually much more simpler than the way I did it. But okay. You multiply by 2B and then J plus 1, right?
I just multiplied by 2B because if you work out like 0 to 1, it would be wouldn't it be like I forget.
Oh, 0 to, oh, I see what you mean. Okay. Yeah, okay. I had a different version.
Mhm.
0 to 1. That should be right. You didn't get the right answer?
I got like 200 less than what the answer was. So
Is
I'm
it
not
oh, sorry to interrupt you. Is it exactly the same question? Because it might be a different version.
Yeah, it's the answer. He posted the solutions to the question. Or maybe I messed up my math somewhere, I'm not sure, but the way he did it, I don't really understand because I didn't get the 1/3. He got 1/3 from part A, but I did it a different way. For part A and I got the answer they got, but for part B I was like 200 off.
Okay.
Nary's not infallible. There could be a chance he did mess up with genuinely.
All right.
Okay.
I get towards T. Okay. Let's see. Do reduce
I don't
mass.
know if you want to work it out quickly and
Okay, you
confirm.
got part A right?
Yeah.
So part A contains B. So what you have to do this. Get your get your answer and then go back to the question.
Um,
I just want to see if it's the same tradition but a different. Okay. It is 0 to 1 and then 2B. Okay. All right. Let me try to work it out. I'm not gonna put in numbers, but I will do. How do I screenshot on this thing? All right. I'll take a picture on my phone. See if I can find it. There it is. And I will work it out.
okay.
Okay, can you stop sharing your screen, please?
Yeah.
And if you get the same answer or whatever, then it must be Renery's fault. It always is. Oh, whoa, I did it the wrong way last time. Okay. All right. So no wonder my answer was weird. So what you would do, so I'm gonna start on part B. So part B is the same thing. So originally you had phi of a j 3 to 4. And you had some answer, and this is equal to, oh wait, not 3 to 4, it's 2 to 3, right? So it's like 2 to 3. Then that's equal to 2b j plus 1. So that's like 3 plus 2 plus 1, which is like 3. Yeah. So what we can do is we can we know this contained B. So what I want to try to do is if you could just try to equal this. To 3 and 4, then this is 3 to 4, and then that's like 0 to 1. Sorry.
Why are you setting it? Oh, okay.
Yeah, sorry. I was looking at the other question, and right there that would be 2b times 1. So what I can do is try to get to this here. And we can do that by doing what you're doing. So to get that to that, you have to divide by 3 and multiply by the reduced mass, like you said, and then divide by the reduced mass. So since you know your first question is right, what you can do is divide by 3, multiply by my reduced mass, and divide by reduced mass. Do you see what I'm getting with this?
Yeah,
So, okay.
that's what I did.
You did that for the whole, okay. I know you did that for B, but I just wanted to see, because if you know for a fact part for A is right, then I just want to see if this is right. So what did you get for your answer for part A?
For part A, I got 7470 or one, whatever answer they had. Yeah, 7470.
74, so, oh, yeah, got 4 there. 7470, right?
Mhm.
So divide by 3, then multiply by the reduced mass, which is,
Why did you divide that by 3? Can't we
because,
just use the B value that they gave us, 3735?
okay, I just want to go to like this here. So since we know that this is multiplied by 1, I want to turn this 3 into a 1, and I want to turn this B into a B prime.
Okay, I think that's a different way than I did it.
What do you say?
I think it's a different way than I did it then.
It's basically the same way, but I'm just using the answer to like work through it.
Okay.
We could use B. I mean, we could just use B if you want. I guess let me just do that. That makes it a lot more simpler. So if they give you B, you said, right?
Yeah.
And B is equal to what's the question answer? I mean?
3735.
3735. Okay, 3735. And so what we're gonna do is what you said, the reduced mass over, and the reduced mass is I told you can do this. So it's like this. Oh wait, I have the correct picture. Never mind. 39. Okay. So that's 39. Minus 27. Oh, yeah. That's 37. Sorry. Yeah. And my phone keeps turning off. $39.37. Okay. Plus 37. 39. I think I actually no, let me just use a calculator. So 39 times 37. Divided by 39 plus 37. Then divided by 39 times 37 divided by, 35 divided by 39 plus 37. You're gonna end up with 3737 times 1.057. And then when you multiply that, what's your question? What's your B value? You got this, right? 3950.
No. 39. I got 19.5
Wait, for your B value?
for my reduced mass for one of them.
Oh, this is just the I meant for what you got for B.
Oh, for B?
Yeah.
I got 3936.
Wait, why are you off by like 50? Oh, it's weird. I think that's probably your problem. Like, let me put what I got for the reduced mass for here. 39, 37. Okay, 18.986. I'll just say 7 because I want to round. And okay, let me just get the same thing. 25.
Yeah, maybe that's the problem because I got 18.5 and 19.5.
18 point. Yeah, I think it's your calculator or something. Like,
Okay.
that's a little weird that you got that.
Okay, because the reduced mass should be this, right? 19 around. Oh, that's the old one.
Yeah, it should be the
Yeah.
old. Yeah, and the new one should be, if I just put this incorrectly, 18.446. And yeah, when you divide that, you'll get this. And you can multiply it by this to get the new B value. So
Okay. All right, that makes sense. For the question, does it have to like can I use this method all the time or does it have to be like in the same state from like 0 to 1 for me to be able to use it?
you can use it for any state. The way I did it was I basically made this, yeah, basically the same thing you did, but I made it more complicated than it needs to. So, but you can use this method when you're talking about changing the reduced mass. You can use it 100%. Just remember, you did it, but multiply by reduced mass and then divide by the new reduced mass. And you
Okay.
yeah.
So if the old state is like let's say 3 to 4, but they want the new mass to be like 0 to 1, I can use this method, right? I just have to change the like the J plus 1,
Yeah, and it doesn't have to do with the transition. It has to do with them.
the B.
Yeah, different, like a different isotope, like this changes here.
Okay.
And if they give you the same, okay, so let's say for example, they say like this is like 0 to 1, and you calculate that, and this is 0 to 1, then you can get your answer, and you can divide by the old reduced mass, and then multiply by the old reduced mass, and then divide by the new reduced mass, because the only thing that changed from one equation to the other would be the reduced mass. That's only for dealing with the same transition we're trying to find, and the reduced mass is changing. Does that make sense?
Yeah, so you're saying I don't have to do like the J plus 1 stuff, right? Like I can just take the B value for 1 and then multiply by the new mass over the old mass.
Yeah, pretty much.
But if it's different J states, then I have to do the equation first and get the B value, and then I can use that B value, right?
Yeah.
to find the new B value.
Yeah, pretty much.
Okay. All right. That makes sense. Thank you. I have one more question.
Yeah.
Okay, so I can share my screen again.
Yeah. Oh wait, let me stop my sharing. Yeah.
So for this one, I got the WE and the WEXE, but the K one is not matching. Well, I didn't work it out, my friend did, but yeah, she said she's not getting the same K value that they have written here. So I was wondering if we could go over the calculation for that.
Okay. Let's see the rotation band, origin, speed, V1, okay. Determine, okay. Determine WE, WXC for a molecule. You still have WE determine the harmonic 2000. Do you have your friend, did your friend write it down? I'm guessing he's in the notebook.
Just give me a second to pull it out.
Okay. Just that determine WE, WXC. That's the fundamental. Time it to be this.
Yeah, I only have she only sent me the calculations for like WE and WEXE or 2WEXE, but I'm not sure what she did exactly for the K one, but I figured you just use this equation, like the new equation for velocity.
Yes. Okay. I just want to like motivational. Okay, so for the first part, I know I posted it in my it's in my review notes, like how you do the first part. But yeah, so I think you can pretty much get that. But the second part is you have to use the reduced mass to find vibrational. Oh yeah, you have to use the so you have they tell you they tell you the molecule. So you have to reduce mass, and then could you just like plug in what V is? What V is, and then just solve for it?
Yeah. Oh, well, how do you get V?
Oh, and V. Oh, by finding what?
Like,
Oh,
what
by
is
multiplying.
C?
I think C is the speed of light. Like
Oh, okay.
it has to be the speed of light because I'm not sure what else it could be.
Okay, so like 3 times 10 to the 8th, I think.
Yeah, meters per second. Make sure everything's in SI units, and then afterwards, you should get newtons per meter. Just make sure you have everything in SI units. So for the reduced mass, it's gonna be like AMU to kilograms, and that's gonna probably be like times 10 to like the negative something, because it's like a reduced mass of a diatomic molecule.
Okay. And then we change the centimeters too for the WE.
It would be meters.
Right?
Actually.
Okay.
Yeah.
All right. So can we just go through the calculation for that?
Yeah. All right.
It's
Let me write it. I think I can write on here because
you want to write it? Okay.
Yeah.
Should I stop sharing?
No, you can. It's cool because I
Okay.
think I can write on here. You can see what I'm writing, right?
Yeah.
Okay. So I'm guessing VE equals that. So we have. I'm just gonna plug in the numbers. Oh wait. Okay. So like we have C, and we have V, and that V here is equal to C times the WE you found. And that has to be the speed of light. And then we got 1/2 pi. And pi doesn't have to be in SI units. It's just 3.14 like usual. And we're trying to find K over mu. So let's put everything to the other side. So we know CWE times 2 pi. So 2 pi is over here. And then that's going to be squared. So we want to take the radical off. And then what we're going to do is we're going to multiply by the reduced mass. And that's equal to K. And then from here, what we can do is put 2 pi. And then it's like 3 times 10 to the 8th meters per second. And it's times WE, whatever that value is, I'm not sure.
It's 2991. It's on the bottom, the answer.
2991.
Mhm.
Does he tell you the units for it? I think it's the same as the W.
Yeah,
Okay.
centimeters to the -1, maybe.
Yes. Okay, so let's put in like 2991, and that's times 10 to the -2 because we want to put it in meters.
Mhm.
Okay. You know what this is. And then that's going to be squared, right? Yeah. Yeah, squared. Let's put a squared here. You follow along, right?
Yeah.
Okay. And then we have the reduced mass of whatever that is. Let's see. Oh, wait.
35 times 37 over
Yeah.
35 plus 37.
Yes. And I just want to, okay, I can put it in my calculator. So 30.
Oh, what? I don't know what I'm saying. It's 1 times 35 over 35.
Yeah.
It's HCl, right?
Yeah. And that's going to be divided by 35 plus 1. That's going to be like 0.972 AMU. And AMU 2 kilograms is AMU 2 kilograms. Okay. And that's times 1.66 times 10 to the -27 kilograms. Okay. That is like a lot of stuff. All right. I think after 972 times 1.66 times 10 to the -27. And then it's going to be multiplied by 2 pi. 3 times 10 to the 8. And it's times WE, which is times 2, 99, oh my gosh, come on, 991 times 10 to the -2. And hopefully I get this question right, squared. And I got this question wrong. Okay. What am I missing here? Okay, times 2 squared times the reduced mass. Huh. I am not completely sure what I did wrong here. Because I did, okay, that's 2 pi, that's okay, that's squared. And that's 3 times 10 to the 8th, 2.2, 2.999. WE. Yeah, I'm not completely sure what I did wrong.
Okay. Did you get the correct units?
I did get the correct units.
What was your answer?
It was 5.13 times 10 to the -6. But that's in per meter. And I'm just trying to figure out why I got it wrong. VK. I put squared there. And then 3 times 2 pi squared. Okay, and then times 2 pi. I think 2 pi should be in the. No, 2 pi is on the right side. Good side, and then times mu. Yeah, I'm not completely sure what I did wrong. I would ask the professor directly,
Okay.
unless the only thing that I think that he didn't that I think I did wrong was I made the equation for VE is wrong, but yeah, I would say try to recalculate it by the way I did it and just plug in values, and then if you still get the same, like you still get like a magnitude less, then I would check with him. Like the thing is that the question, like what I got, is kind of close to what they got, but it's like by like 8 magnitudes.
Yeah. Okay. And how did you get the value of K?
Okay.
Yeah.
K is what you're trying to find, right?
Oh, I
It's-
guess you didn't. Okay. What's
Yeah.
the
I was
the
gonna say put everything to the other side.
okay, I think that's the centimeter value for WE.
Centimeters?
I thought it was K. Yeah, the 2.99 times 10 to the minus 2.
Yeah. What I also think is the problem is C is not, it's probably not the speed of light, so probably something else. That's just a guess.
Yeah, I was thinking it was some constant, but they don't give us a constant here, so.
Yeah, it's weird. I don't know what I did wrong, or it probably has to do with the reduced mass or something. It's probably something else. Probably being a different unit for reduced mass or something, because the reduced mass is making it lowered all the way down.
Okay. I'll ask the professor about that then.
Yeah, I would say just email him. Email Sears actually, because he'll respond quick. If you try to email Ranieri, he's not gonna respond like for days, probably after. So
I wasn't planning on emailing Ranieri. I try to keep my contact minimum with him.
I'm being
I have
honest,
like a sorry.
if I'm being honest, I guess go to his office hours because he's really helpful with office hours.
Ranieri?
Yeah, you'll be
Yeah,
surprised.
I don't know. A lot of people said that, and I started going, but then like he told me I was gonna fail because I'm not very good at calculus, so I kind of stopped going to his office hours.
Yeah, Dimitri, like Ranieri can be abrasive sometimes and not very helpful to some people. But if you know what you're doing in terms of what he wants you to know, you're golden. But Dimitri, you knew what he wanted you to know.
Yeah.
Yeah, I mean, I'm doing fine in the class, so I'm not sure where he got that idea from. But
Prove him wrong.
Prove him wrong. You have linear algebra, right? At least
huh?
you have linear algebra, right?
Yeah, I took linear algebra. I didn't take Calc 3, which I think a lot of people did.
I think you just need calculus. All you need is like, you don't really need Calc 3 for this class.
Yeah, yeah. I had a very, very quick question. I think he made a typo in one of his solutions because he put 10 to the second, but I would have to find that.
Before I forget, let me just clear this. I want to get off pencil mode. Okay. How do I see number of participants? How many participants are in here, James?
4, including you and me.
Oh, did the other person want to ask a question too? I can't.
Yo, Ziwe. Zinwei.
I think I'm all good right now. Are you guys leaving right now?
Office hours are done in 2 minutes, so if you got something, say it. We'll be here tomorrow.
Okay, I think I'll come back tomorrow because right now I don't have any.
Okay.
But
I'm
thank
gonna
you.
I'm gonna stop
Yeah.
recording now.
Okay,